Today we're looking at notes 11-5, add and subtract rationals with uncommon, unfactored polynomial denominators. So the unfortunate thing about today is that not only are our denominators uncommon, but they're not all of them are factored for us. So obviously the first thing we want to do is factor these denominators. So looking at this first denominator here, I would factor this to x minus 5, x plus 2. And that helps me because here I've already got an x minus 5. So what's going to happen is to get this a common denominator, I need to multiply this, both top and bottom, by x plus 2 to make the denominators match. So again, just like yesterday's lesson, keep denominators factored. You want to keep those denominators factored. That is like a big thing. Okay, so on the top, on the first one, I'm going to leave it as it is, 3x minus 15 over x minus 5, x plus 2. Okay, and then plus, on this one here, when I distribute, I get x squared plus 2x over, remember, keep the denominator factored, x minus 5, x plus 2. So then, now that my denominators match, I'm going to combine like terms on top. And while I'm doing that, I'm going to put it in standard form. So the x squared is going to go first. And then I've got a 3x and a 2x, which would be 5x. And then negative 15 doesn't have anything to combine with, so just go ahead and rewrite it. And then over x minus 5, x plus 2. So of course you always want to check, can I factor this trinomial on top? Are there numbers that multiply to negative 15 but add to 5? Well, no, the only numbers that multiply to 15 are 15 and 1 and 3 and 5, and the difference between neither of those is 5. So that is our answer, except we need to include our restrictions of x cannot equal negative 2 and x cannot equal positive 5. So that is my final answer on that one. Okay, so moving on to number 2. So again, you want to factor that denominator that's not factored, so that factors to x minus 4, x minus 3. Okay, this is already x minus 4, so what I need to multiply by on this one is x minus 3 to make them match. But remember, on bottom, I'm not going to multiply back together. I'm going to keep the denominator factored. Yes, I'm going to ingrain that in your brain. Okay, on top here, I've got x squared minus 11 over, keeping that denominator factored, x minus 4, x minus 3, minus, okay, unfortunately, we do not get to keep the top factored, so I need to FOIL. That would give me x squared minus the o and the I minus 3x plus x, so that'd be negative 2x, and then minus 3, so I FOILed, and I did the o and the I together and combined them, got it there, and then keeping that denominator factored, I've got x minus 4, x minus 3. Okay, now that my denominators clearly match, I can combine the top, but look at that minus sign, that's going to distribute. Okay, so we've got x squared minus x squared. Boy, isn't that a gift? The x squared's canceled. And then we've got this negative 2x, but it's minus a negative 2x, so it becomes positive 2x. And then this negative 11 minus negative 3, that minus a negative becomes plus, so that would make it a minus 8, okay, over x minus 4, x minus 3, okay. So now what we're going to have is we're going to factor out that GCF on top, which is 2, so x minus 4 over x minus 4, x minus 3. And then on this one, yay, we do have some cancellation there. And so on top we've got 2 and then x minus 3 on bottom. Again, either with or without parentheses is fine with me. Now remember, we need to look at before we canceled to determine our restrictions, which would be positive 4 and positive 3. There's your final answer. Okay, next problem. So here, we're going to factor that denominator. So here we're going to have to play a little bit of the guess and check game, but small numbers so that won't be bad. So 2x and x, and we're looking for numbers that multiply to negative 3 but add to negative 5. So I'm thinking negative 3 here, positive 1 here. Will that work? So that's going to be negative 6, that's going to be positive 1, and negative 6 plus 1 is negative 5, so we are good. All right, and that makes sense because here we've already got 2x plus 1. So we just need to multiply this side by x minus 3 on top and on bottom. Okay, so here on this first fraction, we're just keeping this the same, not changing anything. Now we are keeping the denominator factored, so 2x plus 1 over x minus 3. Okay, and then here when I distribute, I would get, oh, and that's a plus in between, 5x minus 15 over 2x plus 1, x minus 3. Okay, then I can combine my like terms. It's just a plus in between, no need to distribute. So 2x and then 16 plus negative 5 would be plus 1 over, well, looky there, 2x plus 1 over x minus 3. And again, we have more canceling. This 2x plus 1 with this 2x plus 1. Remember, this x minus 3 does not get a raise. It does not get to go up. So it's 1 over x minus 3 with my restrictions being x cannot equal negative 1/2 and x cannot equal 3. Okay, almost done. Doesn't seem that bad, does it? Okay, on this second example here, I need to factor out my GCF of x, which would leave me with x plus 5. So here on this fraction, I've already got the x, so I need to distribute x plus 5 to make the denominators match. So on top, I am going to distribute. That will give me 3x plus 15. Remember, keep the denominator factored. X plus 5 minus x plus 8 over x plus 5. So then, don't forget about that minus that distributes to both. So here I've got 3x minus x, which is 2x, and 15 minus 8. So that's going to give me positive 7 over x plus 5. Okay, and then for my restrictions, x cannot equal 0, x cannot equal negative 5.